Okay, this is going to be a quick video on completing the square. In this particular application, we're going to be solving a quadratic. There's other reasons that you complete the square, but it's all basically the same idea. Before we begin, though, let's talk about what a perfect square is. So if we're just talking about numbers, a perfect square is a number squared that equals something else. So like 10 squared is 100. 100 is a perfect square. 7 squared is 49. 49 is a perfect square. Now these quadratic expressions here, they are perfect squares. This one would be x plus 2 squared, and this one would be x plus 8 squared. Those are perfect squares. So when you're talking about completing the square to solve a quadratic, what you're doing is you're talking about taking something like this that's not factorable and changing it into a perfect square so that you can solve it. Because if you don't know, if you just barely learned factoring and solving by factoring, you can't solve this. So here's the idea. Here's what happens. You know how you've got your basic quadratic expression or equation like this. We're going to be, just for right now, we're going to be dealing with a being just 1. So the way it works, every single time is you take half of b and you square it, and that's what c needs to be. So like right here, half of 16 is 8, 8 squared is 64. That's how I know it's a perfect square. Half of 4 is 2, 2 squared is 4. So one more example. Let's do half of 12 is 6, 6 squared is 36. And this is very similar to the one we're working with right here. I need this to be a 36. I didn't really have to do this to figure it out, but it's good to know this right here, because what if you had something like this that you had to solve by completing the square? You'd have to take half of 7 and square it. That would be what makes it a perfect square. Okay, so onward and upward. We need this right here. We need this to be a 36, and right now it's a 1. So what we could do is we could add 37 to here. If we did that, we'd also have to add 37 to the other side. And so it would look like this 37 plus negative 1 is 36. And now we have a perfect square. This is factorable. X plus 6 squared equals 37. The next thing you would do is you would take the square root of both sides. X plus 6 equals the square root of 37. Now there's two answers for square roots. There's a positive number and a negative number. Like, for example, the square root of 4 is asking what number times itself is 4. There's 2 and there's negative 2. We use this symbol to make us remember that there's two answers. So your answers here would be 6 plus the square root of 37 and 6 minus the square root of 37. If we were talking about x-intercepts, it would look like this. And here's the other. Now you can't graph that, but what you could do is you could take your fancy calculator and figure out the square root of 37. And approximately that would be 6.1. So on the side right here, 6.1. You plug those values in here, that would be 12.1 comma 0 for one intercept, and negative 0.1 comma 0 for the other. Now let's do one more example. On this example, I did it pretty quickly just by figuring out what it would be. Let's do another that's a little bit slower. So let's do x squared plus 10x let's do minus 4 equals 0. Alright, so first thing you want to check is if it's factorable. And it's not. If it was, you would just factor it. You wouldn't use completing the square unless the instructions said to. Since it's not, what you're going to do is you're going to move the c term. Yeah, so it would look like this. But when you move the c term, you need to leave yourself a little space. So you see you just add 4 to both sides. So you leave a little space, because in that little space right there, what you're going to do is you're going to take half of b and you're going to square it and add to both sides. Alright, so half of b would be 5 squared, which is 25. So you see how b is 10? You take half of it and you square it and you add it to both sides. And it turns out the next step you do is you factor. And if you're ever confused on what the factors are going to be, it's going to be that number right there. Now this one was positive, but if this was a minus 10x, then we'd have a minus 5 right here. But whatever that number you found is, it's right here every single time. So if the factors are ever tricky, it makes it easy. Then you just go ahead and solve. You take your square root, put your plus or minus, and there you go. So if depending on your application, you might want to change this into approximations. You might want to write them as x-intercepts. Depends on the application. Anyway, hope this helped.